Hello there and welcome to Finding Vector Components. Here's our vector. This is an angle magnitude vector. The 16 meters is its magnitude, and this angle right there is 41 degrees. And we want to break that into angle and magnitude. The first thing to do here is to set up a trigonometric angle for this. And here we go. I've just drawn a little crosshairs on here, and this is our x-axis. That's 0 degrees. This is 90 degrees. This is 180 degrees, and this is 270 degrees. And the key here is that our calculator already knows how to find the components of something. All we have to do is use the correct trigonometric angle. So if we start right here, we've got 0 degrees, 90 degrees, 180. This one is 41 degrees short of 180 degrees, right? So the angle that we're going to use is the trigonometric angle. It's 180 minus 41, right? That's 139 degrees is our trig angle. That's what I mean by theta t, okay? Once we have the trigonometric angle, we can use sine and cosine. That's what they're for. Cosine will give us our x component. Sine will give us our y component. So this thing will become, for vector components, 16.0 meters times cosine of 139, and that'll be in the x direction, plus 16.0 meters times sine of 139. Yeah? And we just plug that into our calculator. At this point with your calculator, you want to go into the mode and look in there, and it should say degrees. Okay, if it says radians, you're not going to agree with our answer. Okay, so make sure, and if it says something besides that, you just use the arrow keys, hit enter, hit clear, we're good. And now we're set to find our component. And here they are. This thing is telling me that in the x direction we have negative 12.1 meters in the x direction and positive 10.5 meters in the y direction. And that's with sig figs. So here's our answer. And this makes sense. If we look at this angle here, we would expect our x component to come over to here and our y like that. Since the angle is less than 45 degrees, we would expect a bit more x and a bit less y, and that's what we have. So let's go on to our next one. Here's our next one, and again what we want to do is figure out the trigonometric angle. So let's find what angle this is. So we draw our axes on the tail of the vector there. There's 0, here's 90, here's 180. This is 270. This one is we start here, we go 90, 180. It's more than 270. It's in fact 270 plus 30, right? So our angle is 300 degrees. And now we're all set. Our components are 18 cosine of 300 degrees in the x direction, 18 sine of 300 degrees in the y direction. 18 is our magnitude, so we just multiply it. These give us the coordinates on the unit circle, multiplied by any other radius, and we get the coordinates at the end of the point there. And if we calculate these, we get, yeah, here we are. This is, of course, a 30-degree angle, so we get 9 meters in the x direction, negative 15.6 meters in the y direction. Notice that this makes sense, too. This coordinate here, there's more y than x. It goes down more than it goes over. But notice also that the x-coordinate is positive, this guy's positive, and this guy's negative. And of course this is quadrant 1, 2, 3. This is quadrant 4 right there. And that's what we expect. We expect a positive x, negative y. And there we go.